Okay, so let's take a look at our first example. So let's say you have a gear that when the gear rotates 20 revolutions, 20 full circle, it achieves angular velocity of v equal 30 radian per second starting from rest, starting from v equals 0. Determine the constant angular acceleration and the time required. So to solve this problem, if you are confused about all the angular terms, you can actually think of this just like what we did in chapter 1 with our linear acceleration, displacement and everything. So to do that, you have to look at what do you have. So you have your displacement, right? So instead of the angle, you were given the revolutions, right? So 20 revolutions. What is the value in radian for 20 revolutions? So your displacement will be 20 revolution. One revolution, how many radians? It should be 2 pi, right? One revolution is 2 pi radian. So you should have 40 pi radian of angular displacement. So you got your displacement, and then you got your velocity. You want to find your acceleration. If this is a linear movement, what do you use? If you have the displacement and then you have your velocity, what is the equation that you should use to find the acceleration? Okay, for that, if this is a linear movement, you will use v to the power of 2 is equal to this equation, right? Right, because you have your displacement, you have your velocity and your initial velocity, then you need to solve for acceleration. So similarly, for angular, you use the same equivalent, which is omega to the power of 2 is equal to omega 0 to the power of 2 plus 2 alpha constant acceleration equal to the displacement. So we know it starts from rest, so omega 0 and theta 0 is 0 lah. So you have your angular velocity already in radian per second, so you don't need to convert it, is the t to the power of 2 is 0 plus 2 alpha c and 40 pi. Right, now solving for a c for alpha c, you should get 3.581 radian per second square. Next, you need to find the time required. So if this is a linear, what do you use to find the time? You can use the other two equations, but I think it's easier for you to use the v is equal to v0 plus act, since you already know the acceleration and you know the velocity. So you use the equivalent for angular movement, which is omega is equal to omega 0 plus alpha c t. So you already know the omega 0 is 0. So to get 30 radian per second, 0 plus 3.581 t. So solving for t, you should get 8.38 seconds. So this is how you solve the angular movement problem, which is quite simple.